In the vast expanse of the cosmos, humanity has always been drawn to the unknown, seeking answers to age-old questions and striving for exploration. One of the most compelling quests driving our species forward is the search for habitable planets beyond our own. This innate desire to find and inhabit new worlds stems from a combination of curiosity, survival instinct, and the innate human spirit of adventure. The Exoplanet catalog contains over 5,500 confirmed exoplanets and almost 10,000 additional candidate exoplanets. Exoplanets are planets that orbit stars other than the Sun and thus exist outside the solar system. Exoplanets that orbit in the so-called habitable zone are targets for the search for life outside the solar system. Habitable zone is the distance from a star at which liquid water could exist on orbiting planet surfaces. Habitable zones are also known as Goldilocks zones, where conditions might be just right, neither too hot nor too cold for life. Diving into the world beyond Earth, first let us understand what makes life possible on Earth. Earth is in the habitable zone of Sun, that implying it is at the right distance from the Sun, such that liquid water has been stable in significant volumes over much of the planet's lifetime. It has the right chemical ingredients for life, that is water and carbon, and chemical cycling such as between the planet's interior and oceans by volcanism and other geological activity provides chemical pathways for life to extract energy to survive. Additional factors that have allowed the evolution of complex life are an oxygenated atmosphere and protection from solar radiation by its magnetic field. For outer exoplanets to sustain life like Earth, they would ideally need certain conditions. Distance from their star, they should orbit within the habitable zone where conditions are right for liquid water to exist. Size and composition, they should have a solid surface and be composed of elements necessary for life, such as carbon, oxygen, nitrogen, and hydrogen. Atmosphere, a stable atmosphere with the right balance of gases, including oxygen for respiration and greenhouse gases to regulate temperature. Temperatures should be within a range where liquid water can exist, neither too hot nor too cold. Geological activity, some level of geological activity, like tectonic plate movement, to regulate the planet's climate and provide essential nutrients. Magnetic field, a magnetic field to protect against harmful solar radiation and cosmic rays. Stability, long-term stability in terms of orbit and climate to allow for the evolution and maintenance of life forms over time. Some of the exoplanets found very close to Earth in respect of these conditions are: first one is Gliese 667cc. It lies just 22 light-years from Earth and is at least 4.5 times as massive as Earth. Completes one orbit around its host star in a mere 28 days, but that star is a red dwarf considerably cooler than the Sun, so the exoplanet is thought to lie in the habitable zone. However, Gliese 667cc, which was discovered with the European Southern Observatory's 3.6-meter telescope in Chile, may orbit close enough in to be baked by flares from the red dwarf. Kepler 22b, it lies 600 light-years away. It was the first Kepler planet found in the habitable zone of its parent star, but the world is considerably larger than Earth, about 2.4 times our planet's size. It is unclear if this super-Earth planet is rocky, liquid, or gaseous. Kepler 22b's orbit of 290 days is pretty like Earth's 365. The exoplanet orbits a G-class star like our Sun, but this star is smaller and colder than Earth's. Kepler 69c, it is about 2,700 light-years away, is about 70% larger than Earth. So, once again, researchers are unsure about its composition. The planet completes one orbit every 242 days, making its position within its solar system comparable to that of Venus within ours. However, Kepler 69c's host star is about 80% as luminous as the Sun, so the planet appears to be in the habitable zone. Kepler 186f, this planet is at most 10% larger than Earth, and it also appears to reside in the habitable zone of its star, though on the zone's outer edge. Kepler 186f receives just one-third of the energy from its star that Earth gets from the Sun. Kepler 186f's parent star is a red dwarf, so the alien world is not a true Earth twin. The planet lies about 500 light-years from Earth. Kepler 452b, this world discovered in 2015, is the first near-Earth-sized planet that orbits around a star the size of the Sun. Kepler 452b is 60% larger than Earth, and its parent star, that is Kepler 452, is 10% larger than the Sun. Kepler 452 is very similar to our Sun, and the exoplanet orbits in the habitable zone. At 1.6 times the size of Earth, Kepler 452b has a better than even chance of being rocky, its discoverers have said. Kepler 452b resides 1,400 light-years from Earth. It takes Kepler 452b just 20 days longer to orbit its star than Earth does. TOI 715b, the latest addition to the group of super-Earth ripe for further investigation, orbits a small, reddish star that is, by astronomical standards, fairly close to us, only 137 light-years away. The same system also might harbor a second, Earth-sized planet. The bigger planet, dubbed TOI 715b, is about 1.5 times as wide as Earth and orbits within the conservative, habitable zone around its parent star. The recently discovered super-Earth, TOI 715b, might be making its appearance at just the right time. Its parent star is a red dwarf, smaller and cooler than our Sun. A number of such stars are known to host small, rocky worlds. At the moment, they're the best bet for finding habitable planets. These planets make far closer orbits than those around stars like our Sun, but because red dwarfs are smaller and cooler, the planets can crowd closer and still be safely within the star's habitable zone. The tighter orbits also mean those that cross the faces of their stars, that is, when viewed by our space telescopes, cross far more often. In the case of Planet B, that's once every 19 days, a year, on this strange world. So, these star-crossing planets can be more easily detected and more frequently observed. Humanity's desire to search for habitable planets is a multifaceted endeavor fueled by curiosity, survival instinct, the spirit of adventure, and the pursuit of scientific knowledge. As we continue to explore the cosmos, we may one day find ourselves on the threshold of a new era of human civilization, inhabiting distant worlds and expanding the boundaries of what it means to be human.